All right, so here's what I noticed today when you all were taking the test. Many of you still are struggling with solving trig equations when your angle is a double angle and there's a phase shift happening. And so I'm going to reteach this lesson to you, and hopefully it'll help you to get through this process. So when I solve this equation, it's really difficult to solve because I can't see 2 theta plus pi over 6 on the unit circle. So what I'm going to do is I'm going to let x take the place. I'm going to use some substitution of 2 pi plus pi over 6. And I'm going to solve that equation because I'll be able to find that on the unit circle or on my trig value sheet. All right, so here's what I know. Sine of x is equal to -half when x, the angle, is at, would that be 7 pi over 6? And when x equals 11 pi over 6, I believe those are both the angles for when sine is equal to -half. And we know that the sine function has a period of 2 pi. And since this equation up here has 2 cycles of the sine function over a period of 0 to 2 pi, and that is our restriction here on these problems, what I'm going to do is I'm going to find 2 angles for every answer that I get down here. So I'm going to take all of the solutions for x is equal to sine of x equals -half, and that would be at 7 pi over 6 plus 2 pi n, and again at 11 pi over 6 plus 2 pi n. So I'm going to find all the solutions. Remember, in all the universe, and n is an element of integers, okay? And so now I know the answer to this equation. I can now substitute in the double angle with the phase shift in for x, and I can solve that equation, and then I can use this part of the equation to help me find more answers, or the second angle in each interval. Excuse me. So I'll do blue here, and I'll plug this in for x here. So we're going to get 2 theta plus pi over 6 equals 7 pi over 6 plus 2 pi n. And we're going to solve for theta, so we'll subtract pi over 6 to that side. So we get 2 theta equals 7 pi over 6 minus pi over 6 is just pi, 6 pi over 6, plus 2 pi n. Then we'll divide everything by 2, and we get theta is equal to pi over 2 plus pi times n revolutions. And so here's what I know. Pi over 2 is actually inside of my interval here, so I could say that for sure theta equals pi over 2. And then if I add pi to that, if I make n equal 1, that would take me to, that'd be pi over 2 plus 2 pi over 2 times 1. So that would be 3 pi over 2. That's also in the interval 0 to 2 pi. And if I add another pi over 2, that would take me to 5 pi over 2, which is greater than 2 pi. So that is not part of the solutions for the equation. And then what I'll do is I will pick another color here just so that we can see what's happening. I'm going to plug it in again for this x. And so we get, sorry about that, was trying a different problem, didn't work out. So I've started this video like 5 times here. Okay, so plugging in 2 theta plus pi over 6 equals 11 pi over 6 plus 2 pi n. And again, we're going to solve for theta, so we'll subtract pi over 6. So that would be 2 theta equals 10 pi over 6 plus 2 pi n. And I think I would simplify that to 5 pi over 3. And then, right? So yes, we'll divide by 2, and over here I think I'll multiply times half instead of creating the complex fraction, so I'll multiply times half. So theta equals 5 pi over 6, 2 times 3, plus pi times n. So here's what I know. 5 pi over 6 is a solution. And then if I add pi times 1, I'm doing 5 pi over 6 plus 6 pi over 6 times 1. That's 11 pi over 6. And so that would be a solution. And if I added another 6 pi over 6, well, that would be 17 pi over 6, which is greater than 2 pi, so that's not a solution either. So these would be the solutions for the original equation up here. Notice that the modified equation only had 2 solutions, and then the original equation had 4 because there were 2 cycles of the angle in 0 to 2 pi. So there should be double the amount of angles. And of course you could double check that in a Desmos. You could type in sine of 2 theta plus pi over 6, close your, and then add the half to the other side and equals y, and type that into Desmos and look for the zeros, and you would find that those answers there were the zeros of the equation. So that would be another way to check your answer. You could also do that with the graphing calculator. You could type this in the graphing calculator and look at the zeros for that. So anyway, I thought that might help. So yeah, that's it. That's all I got. 6.5-minute video. See you tomorrow.